Alright, this is a circle. You've met one before. Centre, radius, same distance from the middle to the outside all the way around. Did you come across the circle formula last year?
Yeah, many
Have
times.
like A, X something, B.
Yeah, something.
AX, X squared plus B, A, Y squared equals B squared. Wrong way around.
Yeah, along something like that.
A squared
Oh.
plus y take b squared.
Back to
We'll go from the top of how to make a circle. So on your graph, there should be a nice big graph on the first page. Can you put a point at 0, 0, and then another point at 4 across and 3 up? Now,
Oh, never mind.
if we're going to find the distance from this point to that point, an excellent way to find the distance is to think of it as a right angle triangle, with this length being 4 and this length being 3. And you've probably recognised this sort of 4, 3 setup before and can guess the hypotenuse. But we're going Pythagoras, so 3 squared plus 4 squared is equal to 25, which is the same as 5 squared. This length here is 5. And you'll hit those Pythag triples in year 9 and then again in year 10. It's a very famous Pythag triple. Now, are you happy that if you actually go back 4 and up 3, I'll try and get this as accurate as possible, say minus 4, up 3, that will also be a 5 if you've drawn it well. Because this is a distance of 4, distance of 3, also 5. Sort of making some sense? Same here, we can go, I was wondering that was a fire alarm, again, another 5, and another 5. And if you really want to fill in more of this circle, you can cross the axis here at 5, and here at minus 5, and here at minus 5, and here at 5. Now, it is not just the Pythag triple 3 and 4 that makes it to 25. There are other ways we can make 25. For example, try to say 1 squared root 2. 1 squared plus root 24 squared. Are you guys happy that 1 squared plus root 24 squared gives us a 25?
Yeah.
5 squared. Alright, let's mark on this graph, if this is, say, our x and this is our y, 1 across, root 24 up. I'll do it in purple, but 1 across, it's about there. Root 24 is just less than root 25. Root 25 is 5, so root 24 is just less than 5, it's about here. There will also give us a radius of 5, and that is 1 across, root 24 up. Yeah? It's a bit shaky, especially because my drawing is a bit dodgy, but we're going to sort of extend this round. Are you happy if I did root 3 squared plus root 22 squared? We're also going to get 25. Now, root 3, if you throw it in your calculator, is 1.7-ish. So you're now, instead of going 1 across, you're now like 1.7-ish across. And root 22 is less than root 24, but still above 4, because it's more than 16. So now we're sort of out here. And are you guys sort of happy I can keep this pattern going with a whole bunch of different numbers and create what should be a perfect circle?
That looks fine.
That looks alright, it's not too bad. And we can throw it into the negative side as well, and we can go and get a circle. Oh, it got yeah, it started off well here, and then we stumbled home from the pub through this bit. Pretend it's more circly. So, the point here is we can take any sort of x value and square it, and a y value and square it. As long as they together make 5 squared, they're going to create a point on the circle somewhere. So any pair of values, x across, y up, as long as they're both squared create 25, they give us this sort of circle, which fundamentally is the starting point of our circle formula. X squared plus y squared equals, and this here is r squared. Now, that's a circle centered on the origin. But we don't have to keep it centered on the origin. We can get a little more adventurous. So here's one I made earlier that's definitely more circly. Now, I'll change it to 25 to keep it similar. This is the one we're looking at. The formula looks different because I'm taking away nothing from either side. But do you remember from transformations, what happens if I replace x with, say, x minus 2? What happens to the equation?
It'll go right to.
Yeah, it'll go right 2. So if I make b here be 2, the whole equation shifts right 2. So this is a transformation in the b, and again, it's in brackets, it's the opposite of what you expect. If you put in take 2, it moves to the right 2. And if I put in plus 2, so I make b negative 4, say, it moves left 4. The same pattern happens with y. If I make take a, it goes up, plus a, it goes down. And this gives us our general case for a formula. Our general case is x take a all squared plus y take b all squared equals r squared, gives us a centre at AB and a radius of r units. Alright, so that formula I know you've seen before, but I just thought it worth pointing out that it comes from Pythagoras, and yeah, it looks a lot like the distance formula because that also comes from Pythagoras, and we'll use Pythag in this later. Alright, so what's going to happen is in the questions, they're going to give you pictures of a circle and ask you to write the formula. And they might even give you a formula and ask you to draw a picture of a circle. And I'm pretty confident, you will need to practice that, but I'm pretty confident you don't need my help practicing. What you might need my help with is this type. So, this I think might have been what you were saying earlier, wasn't it? In terms of radius of formula of a circle. Alright. This is a formula of a circle, but in a really inconvenient form. It's called general form. So general form is when everything's expanded and simplified. It's a bit like a quadratic can be expanded and simplified out, but when it's expanded and simplified, you can't tell much. Often it's much easier for it to be factorized, and once it's factorized, then you can tell features from a polynomial or quadratic. In this case here, we are going to convert it back to that center radius form. So we can look at the formula, see the center and see the radius. But that takes some algebra. So what we want to do is our first line is we're going to collect the x's together, collect the y's together, and put the constant on the other side. So x squared plus 6x plus y squared take 2y equals 3. So, sing out. Hello, Mr. Tom. Hello.
Excuse me, would you mind taking a photo of us for The Amazing Race?
Sure. Whoever watches this recording will interlude music.
This one is...
How's the retreat, right?
Oh, that's alright, yeah.
Cool.
No, it's not.
No, what?
What do you reckon you get %? Wow.
They are they tried to crash it, but they didn't do that.
It was what, 34?
Then it would be
Yeah. Oh. Alright, back to circles. Now comes the fun of remembering how to complete the square from last year. So, completing the square is an algebraic trick that you would have used to get to the turning point form. And the key lands with this thing here. We are going to rewrite the x portion, but then we take the coefficient of x, divide it by 2, and square it. And we're aiming to set up a perfect square. So 6 divided by 2 is 3, 3 squared is 9. We're going to add 9 here. And because you can't, and you'll see why in a second, because you can't randomly just add 9 in the middle of an equation without unbalancing it, we're going to have to do something to keep it balanced. And either we can take 9 off here, because take 9 balances the plus 9, or much easier thing to do is just add another 9 there. So we're keeping our equation balanced, we're adding 9 to both sides. Then we pull the same trick with the y's. Y squared, take 2y. Then we take the coefficient of y, divide it by 2, and square it. Then 2 divided by 2 is 1, 1 squared is 1. And we add 1 to the other side to keep it balanced. Yeah.
I think we did do like completing the square and stuff, but I don't think any of us had done it like the other way round. Kind of like we would have done it like, oh, x plus like 3 squared and then take something. I don't know if...
Yeah, and then remove the 9 away.
Yeah.
Yeah. I guess that will work as well, if you're confident. This time I'm just inserting an extra step, I guess. But yeah. So now, I'd like us to just consider this little triple here. And if you're looking at factorising this, you're looking for 2 numbers that multiply to 9 and add to 6. And it should always work out that these numbers are the same. And if you want a bit of a cheat code, the number will be the one in the brackets there. 6 divided by 2 is 3. It turns out 2 3's, 3 squared. This will factorise to x plus 3 squared. And if you expand that out, you'll get back to what I've underlined in purple. Then we pull the same for the other side. Here, you're looking for a pair of numbers that multiply to positive 1 and add to negative 2. That's our pair of numbers. Yeah, negative 1. So plus y take 1 squared. It's also the number that's in this bracket. Negative 2 on 2 is negative 1. Equals 13. Now that is centre radius form. I can tell you that this circle will have a centre of minus 3, 1, and its radius will equal root 13. Because it's the root of that number. So, in order to convert from what we call general form to centre radius form, you need to pull off this trick of completing the square twice within a formula. Okay-ish? Alright, we'll do one more, because it's there. And as you go through the practice stats, we make this happen probably once every year. So you can almost expect one of these questions to appear. Alright, this one here. Same step as before, we want the x's together, the y's together, the constants on the other side. So x squared, take 6x, plus y squared equals 2. Now, let's complete the square for the x portion. X squared takes 6 plus 9 equals 2 plus 9, because I'm taking that minus 6, dividing it by 2, and squaring it. That's what we get to put here. Now, y squared is actually already factorised. There's nothing we can do with it, it just sort of hangs there, which is fine. And then we factorise this portion here. X take 3 squared plus y squared equals 11. Now it's in centre radius form. The centre of the circle will be 3, 0, because that's really y plus 0 all squared, if you're wondering where the centre will be. And its radius will equal root 11. Make a little sense? Cool. So it's basically some algebraic trickery to produce a cool thing here. Your calculators can graph circles. You need a slightly different mode, but it's doable if you want to have a play. However, you don't need to use your calculator very often. As you're going through these questions, it's helpful to draw diagrams of the Cartesian plane, and helpful to remember to use Pythagoras if it's asking you to find distance or find the radius of something, because Pythagoras is your friend. Alrighty.